So I need you to confirm that you can see the screen.
Yes.
So we'll start with this example. It says find the equation of a plane that is parallel to this plane, 2x minus y plus 2z is equal to 6, and also passing through the point 1, 1, 1. So one thing that is one strategy here is to make sure you get you take note of this. The planes are parallel, so they have the same normal. The normal is the same. So it means the coefficients of the x, y, and z will be the same for both planes. What will change will be the constant, the right hand side. So that means the coefficients will look like this. The required plane has the same normal vector, and therefore it will have an equation of this form. Remember, the vectors, the components of the normal vector are the ones that appear here as the coefficients. Right? I think we did this last time. We also told that the plane passes through 1, 1, 1. So if it means this must satisfy this equation. So if you plug it back, we find that D is equal to 3. So we just plug it back into this equation because it must satisfy that equation. And when we do that, we found that D is 3. And we can now write down the required equation. And this is the required equation. 2x minus y plus 2z is equal to 3. Tuko pamoja?
Yeah.
Good. So this one was too simple. I should not bring like this one in the exam, I think. I should bring the one you can't understand. So no one is answering. So this one also is a technique which helps you to tell where a point in space will be on the origin side or the non-origin side of the plane. So anytime you pick a plane, it cuts the space into two equal spaces. One side is towards the origin or contains the origin, and the other one does not contain the origin. Or if it's a plane through the origin, then it definitely contains the origin. It will always contain the origin. So the point is, if you pick any point outside the plane, how do we tell which side it's on? Is it on the origin side or the non-origin side? And I think I'll let you read this as an exercise. But eventually, this is what you come up with. What the proposition says, it says that it depends on the following. This quantity. Did I write this in full? It depends on whether this quantity and D are of the same sign or of opposite signs. So if they are of the same sign, it should be on the origin side. If they are opposite signs, it should be on the non-origin side. I'm not sure whether I need to add D here. I'll check this. There's something here I'm not sure about. I'll check this one here. Remind me to get back to you or in tomorrow's class.
Yes.
So the proof, what follows is just the proof. And then there's an example where you can apply this. Yeah, and you can see in the example D is included. Yeah. That was what I thought. So this example applies that test and is able to show where these 2 points lie in relation to the plane. X plus 2y minus z is equal to 5. When you apply that test, you work out this, and you can see that this is negative and this is positive, so they are of opposite signs. Again, for this second point, this quantity is still negative and this is positive, so they're again of opposite signs. So both points must be on the same side of a plane, I think, as the origin. And with that one you can check, because the calculation is already done for you there. You just need to go back and go through it. I will share the file. So here's an example. It says find the distance of the point 1, 2, 3 from the plane 2x plus y plus z. Before we do that, I think there's a formula I've skipped. So the perpendicular distance of a point x, y, x1, y1, z1 from a plane ax plus by plus cz plus d is equal to 0 is simply given by this formula. I've left it as an exercise for you to try and prove this. So this, if you want to find the distance between a given point and a plane with this equation, this is the formula you use. Okay. So we apply that formula in the next example. It says find the distance of this point 1, 2, 3 from the plane 2x plus y plus z. So again, remember this is the formula we need to apply, where a is 2, b is 1, c is 1 again, and I think d is minus 3. So we apply that here. We get the distance is 4 over the square root of 6. So this one is quite simple. The only thing now you need to do, try to prove this theorem here. Try to look for the proof. Get some work to do there. Now we want to consider the angle between two planes. So anytime you have two planes, you have three options. They can either be parallel, they can coincide, or they have a line of intersection. So those are the three possibilities. If they are coincident, then the angle is 0. If they are parallel, the angle is 0 or minus. It's 0, I think. If they are parallel or coincident. If they intersect, they will have some angle between them and 0. So let's see how we find that angle. We go through the following proposition. It says the angle theta between the planes a1x plus b1y plus c1z plus d1 is equal to 0, and a2x plus b2y plus c2z plus d2 is equal to 0 is given by the inverse cosine of this quantity. So again, let's prove this. So we're given two planes, then we want to find the angle between them. So the strategy here is to realize the following, that the angle between the two planes is the same as the angle between the normals. So if you get the angle between the normals, it's the same exactly as the angle between the planes. And we can find the angle between the unit normals as n1 dot n2. I don't know if this should make sense to you, because the dot product of two vectors is supposed to be equal to the product of the magnitude of the two vectors multiplied by the angle between the two vectors. But now these two vectors are unit normal vectors, so their length is 1. So the product of the magnitude will just be 1. You'll be left with only cosine theta. So that gives us, if you get the dot product of n1 and n2, we work it out here. And now to find theta, we have to get the cos inverse of this. You work this out. You'll have a1, a2 plus b1, b2 plus c1, c2, which is what appears here. Then at the bottom, you just multiply these two quantities. And there you are. So I hope at this point you can see what we are doing. When you have a plane, these coefficients A1, B1, and C1, that they form a vector of the normal, but what we wanted here was a unit normal. So we are dividing by the magnitude for each of them. So we have this, the normal vector. If you divide it by its magnitude, you get the unit normal vector. The same here, you get the unit normal vector. So you're getting the dot product of two unit normals. And that's how you get the answer. So the angle is simply this. So if you want to understand this, let's look at this drawing. And now there are two angles you can pick. There's one angle, there's this angle theta, and there's another angle here which is pi minus theta. So it will all depend on which angle you're looking for. But once you find one of them, the other one is simply pi minus theta. So I've taken this part of the drawing, this part, and I've put it here. So this small n1 represents the unit normal to this plane here, and this n2 represents the unit normal to this second plane. Now this angle, this is the angle theta. It's the same angle theta here. And if this is a unit normal to the plane, you can show that this angle here between these two unit normals is also theta. Can you see why it's theta? If someone can tell us why it's theta, we can give them 50 MB instantly. Ama mnataka nibaki na 50 MB yangu? Is my microphone on? Oh, there are many people waiting to come in. Hakuna mtu anataka 50 MB?
Mwalimu, si unitumie?
I need an answer. That is a deal. Tell me why this angle is theta. The angle between the normals is the same as the angle between the planes. So why is that the case? Remember, this is normal, so this angle here is 90. This one is normal also, so this angle here is 90. Nataka 50 MB bila kujibu. Muturi. You have disappeared. Nobody has the answer. Ama muko na MB za kutosha?
No.
You want to attempt?
Yes, I can.
Okay, then explain now. So tell me where to point as you explain. Na usiweke kizungu mingi sana.
Can I answer?
Yes.
So the first theta,
Yes.
yenye iko hapo on the left side ya
This one I'm pointing.
N2. Yeah,
This one.
there you.
Mm-hmm.
Yeah. So if on the right side,
This one.
on the right side, yeah, see only normal.
Yes, it's a normal to this plane.
So the
This
angle will be 90.
Yes, this is 90.
90 minus hii angle iko hapo chini on the triangle. So that brings the angle theta.
So this angle here is 90.
Yes, 90 minus that angle.
90 minus theta. Because of theta here. This is already 90. So these two must add up to 90. So this should be 90 minus theta. But because this angle is also 90, this one has no option but to be theta, so that these two will add up to. So 90 minus theta plus theta should give you 90. Is that what you're saying? or you're just following what I'm saying?
That's what I'm saying.
Maybe I have won the MBs myself. You remind me to send.
Hiyo lazima nitakukumbusha hiyo.
Tanikumbusha? Okay. Hiyo uko na bidii. So the next example says find the angle between these two planes, 2x plus y minus z is equal to 5 and x plus y plus z is equal to 0. So the normals are, as usual, you just pick the coefficients, 2, 1, negative 1, and here it's 1, 1, 1. Then the angle, when we apply our formula, this is what we get. That's the angle. And it's cos inverse root 2 over 3. So in this course, you don't have to give the actual answer. If you leave it in this form, that will be just fine, because you can't even get the exact answer. So it's best to leave it in this form. And and we're not testing your ability to find this angle. It's your ability to use this formula. So you can always leave this in that form. So tuko pamoja? So here's another example. This one says find the equation of the plane which makes equal angles with the coordinate planes and passes through the point 1, 2, 3. So so this plane is supposed to make equal angles with the coordinate planes. So that means it should make the same angle with the x-axis, the same angle with the y-axis, and the same angle with the x-axis. That's what. So not only that, it also passes through the point 1, 2, 3. So the solution says, let the plane, we assume the plane takes this form. So we use the information given that the plane has the same angle with all the other planes. So here, this is how we compute the angle or the cosine of the angle between them. So they should all be equal, right? And when you work it out, you have A over this is equal to B over the same, C over the same. So this means that A must be equal to B and must be equal to C as well. So we can write the equation as x plus y plus z is equal to D. Because if you have the same coefficient, you can always divide through by the same coefficient, and you end up with one constant on this side. So we also know that it passes through the point 1, 2, 3. So that point must satisfy this equation. So when you plug in the points, 1 plus 2 plus 3, we should get the value of D, which is 6. So the required equation is x plus y plus z is equal to 6. So here we now want to look at what happens when you consider two planes. Right? So it says two planes, say A1x plus B1y plus C1z plus D1 is equal to 0. And this second plane, A2x plus B2y plus C2z plus D2 is equal to 0. They are parallel if this happens. They are parallel. These ratios will be equal. A1 over A2, B1 over B2, C1 over C2. So that means they have the same normal, or their normals have the same direction. So that's why this happens. So it's something you can prove. And they are perpendicular if the angle between them is, angle between their normals is 90 degrees. So if the angle between their normals is 90, then the dot product of the normals will be equal to 0. So that tells you that the two planes are perpendicular. So keep this in mind. You can check that they're parallel if these ratios are equal and they'll be perpendicular. The dot product of the normals is equal to 0. You know that two vectors are perpendicular if their dot product is equal to 0. So again, you can prove this as an exercise. So here is an example. So determine the values of lambda and mu for which the planes mu x plus y minus 2z plus 4 is equal to 0, and 6x minus lambda y minus 4z is equal to 5 are parallel. So we have this constant here, mu, another constant here, lambda, which we don't know, so we need to find it. So this is mu over 6. If you compare the ratios, if they are parallel, then mu over 6 should be equal to 1 over minus lambda, and also should be equal to minus 2 over minus 4. And so this, the one on the left can be fully computed. This is the same as a half. And then you can use that to find lambda and mu. So you'll find that lambda is equal to -2 and mu is equal to 3. When those two values are put back into the equation, the two planes will be parallel. So next example, show that the planes, these two planes are orthogonal, and then you find the equation of a plane through the origin, which is perpendicular to each of these planes. So to check that they're perpendicular, you simply get the dot product of the normals, and here when you do that, the dot product is 0, so they're definitely perpendicular. So the second task is to find the equation of a plane through the origin, which is perpendicular to both planes, right? So let the required plane be AX. So we don't know the plane, but we know it passes through the origin, right? Through the origin. So if it passes through the origin, it means this constant is 0, and it will take this form: AX plus BY plus CZ is equal to 0. Now, we want it to be normal to both planes. So that means the dot product of the normal of this plane with both planes should be 0. So we end up with two dot products, which are equal to 0. This is the condition we want to be satisfied. Now, there are some techniques for solving this. We have not done linear systems of linear equations. But for now, we'll just write it down. When you solve them simultaneously, it should be possible to write each of them as in this form. A will be minus 6k, B is equal to 6k, and C is minus 3k. You can write each of them in terms of a parameter. So, so you could put them in here, but when you divide through by minus 3k, I think, you end up with 2, minus 2, and 1. So this is the equation of a plane that is perpendicular to both planes. I don't know if I'm making sense there. So the next one says if A1x plus B1y plus C1z, and these are two planes. We have two planes. So how do we set up an equation that represents both planes? Since you know that this quantity is equal to 0, and this quantity is also equal to 0, it means if you multiply them, we should also get 0. So for any points on the two planes, this product should be true. So now this represents a quadratic equation in x and y and z. And anytime you can write quadratic equation in this form as a product of two linear factors, then it will represent a plane, two planes rather. So on the other hand, if the quadratic equation, someone needs to mute. So on the other hand, if we have a quadratic equation in the three variables, and it's possible to write it as a product of two linear factors, then it definitely represents a pair of planes. So in particular, if we consider this quadratic expression here equal to 0, this one can only be, it's possible to write this as a product of two linear factors if the determinant of this matrix here is equal to 0. So when the determinant of this matrix is 0, it's always possible to write this as a product of linear factors. Now, what you will notice here is that the constant term is missing. So what we are looking at are planes through the origin, because the constant term is missing on this side. So this second part is simply considering equations that go through the origin. Yeah, so anytime you want to check that such an equation represents two planes, then you just need to check that this determinant is equal to 0. Right? That's the same thing we're saying. So I think that will stop there today, unless there are questions. Mkuna swali?
So will you share the video today?
Yeah, I hope I will. Let me see if I can today. I'll try to do that today. You are in a hurry to watch it?
Of course, today I've understood nothing.
Did you eat lunch, man? I couldn't. So another reason maybe you've not understood is you need to have read the previous notes. Some of the information we are using now is in the previous notes. So if you haven't read them, even if I share the video again, you will not understand. So you need to read the previous notes, because some of the information is from there. Yes, I'm sharing the notes shortly, so don't worry. But if you want to understand what lies ahead, it's important to read what is before. So if you haven't read what is before, it's very difficult to understand what lies ahead. So Namasaki, have you read the other notes?
Of course, I have read them.
And you don't see any connection with these ones?
I see the connection, but some.
Yeah. Okay, I will share the notes. But if you have any questions, you should ask. And also try to just give the class your full attention. It works better that way. When you come to class, put anything that is distracting you. Kama Chelsea, unaweka kando.
Chelsea lazima tuweke kando.
Yeah.
I'm doing a football fan.
So, but you must have something you are a fan of. So you put it aside and focus on the class fully. For this online learning, it really requires your full concentration. If you don't focus, you lose out a lot. And if you read the previous notes, then you have a better chance of understanding what is what is taught next. Read and solve the problems in the previous notes. Aguero, wewe umeelewa?
Niko poa.
Oh. Then you should talk to Namasake.
Ni sawa.
Namasake,
Yes, sir.
maybe Aguero will teach better than me.
Maybe.
Yeah. Maybe a very skilled teacher.
So I'll try to consult.
Nitamwambia asikulipishe.
Hawezi. Aguero is a kind person.
Okay. So anyone else who has not understood anything? So I'll be sharing the notes in a minute. Then you'll have a chance to read them again. But you really have to pay attention in class, and also once you get the notes, read them. Not just reading them, you read and try to solve the problems that are in the notes. That's the best way to do this. There's no, like I told you, there's no way you can learn maths by staring. You actually have to compute. It's very difficult. There's no shortcut. Lazima uchukue tu kalamu na karatasi. You do the calculations. Unless you're one of these people who have very good memory. Do we have some here? Today the class is very quiet. Okay, I think maybe you are tired. You need to go. I will let you go, and we'll meet again tomorrow.